Welcome to the Throttle Up podcast, a behind-the-scenes look at what it takes to build and launch a new class of rocket propulsion. Hosted by Sascha Deri, founder and CEO of bluShift Aerospace, and storyteller and entrepreneur Justin Starbird. This podcast follows the real work behind the mission. From early design and propulsion development to testing, capital, partnerships, and the path to launch, each episode brings you inside the process as it unfolds. This is your front row seat to watching bluShift Aerospace take off.
Welcome back to the Throttle Up podcast. My name is Justin Starbird, and I get to welcome back co-host Sascha Deri. Sascha, great to see you, buddy.
Nice to be back, Justin. I really appreciate it.
Yeah, it's great to be here. Today is pretty exciting. I feel like I say that all the time with the different topics that we come up because every one of them is pretty novel and new, and there is a lot of optimism in the air and energy around us. And but I'm pretty excited to announce what hear about the announcement you're going to make next.
Yeah, it's so we're very excited for our next hot fire test of the MAREVL Engine is happening on July 16th. And as a lot of the investors will find out, we'll be sending out invitations for you all to attend. These are people who have previously invested in our company. The show, demonstrate, give everybody an opportunity to see the innovation our company has created with the investments from not only from investors but also from the government and shortly a large commercial customer of ours.
That is so cool to hear and to see, and you've said it out loud, so it has to come to fruition now.
Yes, yeah, July 16th is going to happen one way or another. Yeah,
rain or shine, snow, whatever. We're in right now.
I hope it's not going to be snow. I'm at the test site right now, and so about 100 feet away from the test cell, and everybody will be on the opposite side of the runway there under a tented area. It'll be nice. We'll have refreshments. Going to probably be inviting folks, not only investors but also folks who've been part of our success throughout the years, as well as there's a lot of kids we'll be inviting too that are inspired by aerospace that we're going to bring in as well.
Oh,
friends and family.
Yeah, I can't wait. I'll be there too. It'll be my first test. Before we, I don't know, we hear about upcoming tests. There's, of course, space has been in the news a lot in the last couple of months with the Artemis coming back to Earth and SpaceX going through their IPO. But so people have this conception what a test is as a zero sum, either you pass or you fail. But that's not really true. There's a lot of nuance and things that you're looking for. So it's not did it go straight up and come back, or in this case, did it fire up or not? Like talk a little bit about what you're looking for in a test.
Yeah. So, I don't think we've ever had a test besides, well, I was going to say, even in the test that we have to scrub, you end up learning something about your systems and operations. But we have not had a test yet where we don't gain a significant amount of data information that we can analyze and improve the engine in the next test. And this time is definitely not going to be an exception. I think I might have said this in some of our investor calls the last several months, but the amount of changes that have been made internally in the engine are significant. The amount of analysis that's gone into the thermodynamics, the behavior of the engine are significant. And so, but you won't see much from the outside. You'll still see a white cylinder, which is our combustion chamber, where our solid proprietary high thrust fuel is stored. And I wish I could share with folks what's all in there, but we're going to be gathering a lot of data. The objectives on this test are to improve performance even further and to improve combustion stability even further. But boy, like every test that I have, there's a long pucker moment where you probably don't breathe for about 60 seconds in my case. Uh, it's like the most anxiety provoking slash exhilarating experience that I have on a semi-regular basis.
Yeah.
So I'm looking forward to sharing that with everybody.
When you say that you're looking to get more out of the engine, what does that mean when you say something like that?
Yeah, so uh, with any rocket engine, you're always trying to get what's called the combustion efficiency. Think of it as your miles per gallon. You want to get that up because unlike a car, you have to carry both your fuel and your oxidizer. We don't have the luxury to just breathe in the air the whole time. So, so you really want to squeak out as much performance as you can get, in part to reach the objectives of, in our case, for suborbital applications, the altitude. Um, or in the case of supporting hypersonics, you want to get up to a certain speed at a certain altitude. And there's also a point where if you don't have enough performance, you can't go beyond a certain payload size. You're limited, more limited than you might want to be. So increasing performance means you go farther or you can carry more, which both usually means more revenue.
Yeah.
And then the other thing is refining stabilities. Even though like our last engine test was our best one yet, we had sufficient performance that in a suborbital configuration, if it was launched, we would have gone higher than Blue Origin would have gone with their suborbital launch services or Virgin Galactic. But we want to do better yet. And in the years to come, we'll do better yet because we'll go from using a metal alloy-based vehicle and combustion chamber to largely composites. But that's for later. Now it's all about let's crank up the performance a little better and let's get stability even more refined. And then we begin the next set of test campaign objectives, which I'd love to share with you. And maybe I'll say that for a moment later.
Yeah,
Depending what you want.
one of my questions to follow that up is, when I spoke with the guys before, they were talking about how similar to what you just said, no test is a failure because you're gaining so much data and
Yep.
information. It's different for you as CEO and founder, the data that you're getting, you have numbers that you're also trying to hit to be able to deliver to your first customer as well. So you have a lot of things that are going through your mind. So, think through or share with us what are those elements that you're really measuring for that have a meaningful difference relative to say, what you've done in the past.
Yeah, I think the team and I are pretty well aligned with where our major objectives are. We know it's in a suborbital configuration, it's altitude and time that we can offer in zero G for research customers. And we know for as a test enabling very low cost booster for hypersonics, we know what speed we need to get up to given certain payload weight. So I think the team understands that, and we're all shooting for the same thing. The Where we might differ is when it comes to like suborbital research payloads, uh, you don't really want a lot of instabilities as you go, vertically up. Those extra vibrations mean you might loosen wires, you might loosen fixtures in experiments, and a lot of customers won't tolerate that. So for me, that's probably one of the only areas where I have a lower tolerance for the outcome of our performance than we might have otherwise technically. I think at an engineering level, there's the main focus is make it past 100 kilometers. Okay, give our customers ability for more zero G time than anybody else. And then, can we support hypersonics? Yes, check, check, check. We're good. So I think it's a subtle difference. The the uh, the other the other thing that I would say that is less about tests other than they manifest themselves in the tests, is the choices we make in design. So one of the things that doesn't come out in public, I think, much is when you're designing to make the best engine, that be where the best performance, no matter what, is the only objective, you have a certain outcome. When you are thinking about, well, we're running a business, we have certain objectives we want to hit for the customers, but we need to make it cost effective to them. We need to beat the pants off of our competition. And to do that, it is not always the most intuitive solutions. There's like go-to book solutions for different things. And part of, I'm now alluding to something, by the way, part of the stuff that's inside our engine that you can't see is a very unique choice, engineering choice, that will maintain a lower cost of our engine versus the competition, yet enhance its performance and ultimately stability as well. So these are kind of the choices you make that don't come out in public. And I think what happens when you have the alignment of business objectives and engineering objectives, and you think about it as like, no, how can we make more and faster? I think of like SpaceX, right? They're still losing billions of dollars per year, right? Still going IPO. And whereas I think about it, somebody who's run small businesses for decades, I think about it, all right, I need to create real good value for my customer, but I also need real good margin so I can grow. I can continue to put R&D monies to stay ahead of the curve, and so we can grow our manufacturing capacity, and so that we're profitable, which is ultimately better for my investors, better for my customers. And so I think when you have that in mind from the get-go, you make different technical decisions, and I am very proud of our team, because I think we share that objective, being smart about being wise about how we solve problems. That isn't necessarily the easiest and already well-known path, but the more expensive one. But what is a perhaps unique way? We're not choosing uniqueness to be unique. We're choosing uniqueness because it is the more cost-effective yet capable solution for meeting our objectives.
So here's a dumb question. I think, why don't more companies think that way? In terms of, you mentioned that you have, whatever company out there, can't say company X anymore because that's an actual company, but when you think about a company that's out there, they're only trying to get as high as they possibly can, or they're only trying to go up as quickly as possible, or they're only working on one of those objectives. Is that a build it, and they're hoping, and the engineers are hoping that the business comes, or is that driven by something else? Because I like to think the way you're looking at it. I know it takes one Mainer to know another Mainer. I know we don't get regional on this show very often,
Yeah.
or we haven't yet, but that's the practicality, I think, of the business that comes out to where you're trying to make it as efficient as you possibly can for the customer while making it cost effective. Because at the end of the day, although they're essentially paying you for this eventually, you wanting to get the most value out of it. And that, I feel I was born with that same ethos as well. Why don't more companies do that?
Well, yeah, and by the way, I think there's something like, it's almost like farmer wisdom. Like, how do you get stuff done? Solve it on the farm, right? Well, I come from a family of farmers. I am not a farmer, but I think there's like that
Same,
sort of
by the way.
Yankee.
Yeah, I have
Same
the
thing?
same thing. Uncles and one side of the family, all farmers,
Yeah.
north of here, and I'm not.
Yeah, exactly. Yeah. So it's like farmer ingenuity and cost effectiveness to solve the problem, uh, as opposed to like perhaps like West Coast flash and dazzle. Why? You know, I think part of it is we as a country, like you take NASA, we have a very long history of doing amazing technological advances and putting amazing amount of money into that, right? And to bring up SpaceX again, like SpaceX is really a good example. Has done, amazingly innovative things. And a lot of that a lot of the innovations come from, the vast majority I shouldn't say the vast, but majority, but a lot of that comes from the people there. But also a lot of that innovations come from AFRL, Air Force Research Labs, and others. I know like $1 billion was put into the government supporting the building of their latest engines. And that's kind of, there's a sort of pride into like pushing everything to its absolute limits. But the problem is, it's kind of like CPUs. I'm also a person who, like, since I was young, I used to put together computers, right? Buy your own CPU, buy your own video card. And like if I'm going to buy like the best of the best of the CPUs, there's this inflection point where you're going to pay twice as much for something that's maybe 10% more efficient, right? And I say, well, you know what? I'm going to back it off to make it more cost effective. And the same thing could be said in the propulsion world. You can make something be phenomenally more expensive, whereas if you just look back and say, you know what? Can we still solve this problem? And if we solve this problem in a more cost-effective way, that's something that's 90% the ultimate solution. And if the answer is yes, you should probably consider that. But I think we in this case, I'm talking about like we as folks that work in the technical regime of aerospace engineering, mechanical engineering, we love the best of the best of the best. Like that, like there's a big part of me that resists, a lot of really dazzling technical choices. And I think that is in part of the ethos of aerospace engineers and not everybody, but a lot of folks. And especially when you have the option for you have that capital that you can put to use to do some of these really expensive, innovative solutions, then that you become kind of addictive. You can kind of get into that. So I think it's sort of part and parcel. You want to do something that's never been done before. You want to do something that's pushing materials to their very utmost limits. And, we do too. But if you look at something from a macroscopic scale, you need to look at what is this going to mean? If I make this choice, what's this going to mean not only from when I make the engine, what does this mean from an operations standpoint, which is going to cost me money, which is going to cost my customer more money. So do I choose LOX? Well, that means I need an ongoing supply of liquid oxygen wherever I'm going. That means I have to deal with all the cryogenics, all the costs associated with that. So all these types of these considerations that I think don't necessarily enter one's mind if you're focused on, I need to design an engine. But I think that's where we're different. We're trying to design a solution, and the engine isn't a very important part of that. But how we operate logistically as a company and the operations flexibility we provide to customers and the cost effectiveness of that is the ultimate objective.
So let's switch gears and go back to the test a little bit in terms of, what you're actually testing for, because you mentioned a moment ago that with the previous test, you actually were able to go higher than Blue Origin, or if it had launched straight up, then you would have been able to go higher than Blue Origin and Virgin Galactic, who seemingly have significantly deeper pockets than bluShift at this stage. How is that? How are you able to do that? And walk us through what this test will actually be for. What kind of milestones will it start to unlock for you?
Yeah, I mean, to be fair, I mean, Virgin Galactic and Blue Origin are focused on they're primarily focused on sending tourists to space, right? And so it's to provide that experience, and as a secondary offering, they provide the ability for research to go up to space. So it's not their main intent. And I mean, to their credit, the amount of money they have to put into it is immense, because if you're needing to ensure human safety, it's probably a 100x fold difference in cost. And since we have zero intention to send up humans in any of the boosters or vehicles that we're making, it doesn't even enter into our mind. So so that's part of the unfair footing that we stand on, right? And it is amazing what they're doing to safely take humans up and down in space. Um, uh, in terms of what this test is that we're doing right now, what we're looking to do is to iron out the instabilities a bit more and hone in the performance a bit more, because potentially the very next test that we do could have our lightweight combustion chambers. Right now, we have a very heavyweight, high factor of safety combustion chamber, but we are eager to start testing out a version which is what will be the flight-ready version of our combustion chamber. We already are. We've been testing for now some time with the flight-weight version of our oxidizer tank. So getting that ironed out, here I am, like actually using an iron, right? I think I ironed my shirt today too.
And you look great, by the way.
Oh, thanks, man. Yeah, you can't see all the wrinkles. So if the test goes well, and if we keep the stabilities below a certain point, we know we have the confidence to safely test in our flight weight combustion chamber, which can be, we'll be able to manufacture very quickly. So that I'd say that's the biggest objective. The other thing is that depending on when the tower is finally constructed at a another 20 feet, that next test could occur vertically in that tower, which is also like going to be an earth-shaking, incredible test where I will pucker heavily for 60 seconds. Actually, that's not true. I will not be puckering for 60 seconds, because those following tests we will be burning the engine twice as hard for half the amount of time. Same amount of fuel, same amount of propellant. We're just going to crank it up by 2 and burn it all that much faster. And so it'll take about 30, 31, 32, 33 seconds to burn all that fuel instead of 60.
Wow.
Yeah.
That is a lot to look forward to. Now, talk a little bit about who is invited to the test.
Yeah, so we're inviting folks who've invested in our company to date, who've made what we've done a reality. A lot of people who understand our vision, the markets we're going after, and how we're really different than what you normally see when it comes to boosters and rocket propulsion. So folks like that are coming. There are folks at a state level and community level we'll bring in too. And like I said, we're going to be opening the doors to our future aerospace engineers as they work their way through elementary, high school, and college. That's amazing, because we've been around. I got to say, as a person who has kids myself, younger kids, it's been amazing to have now kids who were interns with us in college now entering into workforce, some of them working for us, but also see kids who've come to visit our test sites, now fully adults working in the aerospace world and in engineering, and that I love to see as a father myself. So that's always kind of part of our ethos when we do these tests too, to bring in and encourage the next generation of aerospace engineers.
And to do that from Brunswick, Maine is also pretty exciting. Although there are surprisingly more rocket companies in Maine than you would expect, it is really interesting to see.
Yeah, it's amazing.
So, well, we'll definitely look forward to this, and we'll be sharing this episode with the invitation to folks to attend. If you'd like more information, it'll be on bluShift aerospace.com. Sascha, as always, man, this was great. Thanks so much for joining me today.
Thank you, Justin. And I guess I'll share that one other thing is that, like always when we do engine tests, we're really remarkably transparent, uh, kind of sharing the good, bad, and the ugly. We will live stream this test like we do every time. You have to be patient with us. We don't have the audio and visual equipment that you might expect larger launch companies to have or rocket companies. But it is fun. It's interesting. The comments are, really funny comments, some pretty sarcastic, but man, it's a good time. And I will hop on the line. I'll answer questions for people live. And then I'll pop out of the RV and talk to the folks in person that are watching there, give them my immediate response after a test. And so even if you can't make it, you can make it. You can make it live. You can make it on our live stream on YouTube.
Awesome. Well, thank you so much for sharing today. We'll definitely look forward to this, and we'll definitely do a post-test follow-up show to, maybe with you and some of the team as well, get your feedback and reactions.
Definitely. That'd be fun.
On behalf of my guest today, Sascha Deri, the CEO and founder of bluShift Aerospace, you've been listening and hopefully watching the latest episode of the Throttle Up podcast. Until next time.